Hi, my name is Angie. In 2024, my friend's mother was diagnosed with melanoma from what seemed like a very ordinary mole. And with early detection being so crucial for survival rates, I started thinking, what if your phone could detect skin cancer from an image? And so I spent the last year building that exact solution. This is Dermi. Skin cancer is the most common cancer in the world. In fact, 40% of all cancer diagnoses are related to the skin, and 1 in 5 Americans will develop skin cancer by the age of 70. But the real crisis is one of access. Globally, over a third of all countries have fewer than one dermatologist for every 100,000 people. Basically, that leaves at least 3.5 billion individuals without any realistic path to seeing a specialist. So, what's the solution? This is where Dermi comes into play. Dermi is a freely accessible, AI-powered mobile app I designed to predict skin lesion diagnoses and educate users with knowledge about their skin health. But how does it all work? The engine is a convolutional neural network, also known as a CNN. Basically, it's a type of AI that learns to recognize patterns in images, much like the human brain. I built the system by training the model on over 77,000 dermatological images from gold standard medical archives, such as ISIC and HAM 10,000. Specifically, I used a technique called transfer learning, essentially taking a powerful pre-existing model and specializing it for dermatology. After developing and testing over 40 different model iterations, the final architecture, called Inception V3, achieved over 83% accuracy with a critical 87% recall for malignant lesions. In simpler terms, that means the model identified 87 out of every 100 potential cancers, because catching the dangerous cases is what matters most. Of course, this is just a foundational model. Currently, I'm also working to expand the model to differentiate between hundreds of skin conditions and also tackle a major challenge in medical AI, mitigating racial bias, to ensure it works equally across all skin tones. But more on this later. So, how does all of this complex technology translate into a simple, user-friendly app? So this is Dermi. On the home screen, you can see recent scans, quick actions, and real-time stats. First, the Explore page, a database with over 60 skin conditions, each with symptoms, treatments, and photos from DermNet, a gold standard site. There's also an integrated blog system with educational articles about skin health topics. You can also search by condition name, like melanoma here. Each condition card gives you a quick overview and also a detailed description. You can also filter by symptoms instead, such as bleeding or lesion growth. Based on that, Dermi shows matches, in this case, basal cell carcinoma. Now, for the scan tool. This 3D model I built in Blender and integrated with 3.js lets you zoom, rotate, and long press to mark exactly where a lesion is. Right now, I'll pick the right leg and take a photo. After cropping, the scan is analyzed by my AI model hosted on AWS and Render. While it processes, I'll close the analyzing modal and show the Find Clinics page. This function locates nearby dermatologists with distance, ratings, and directions via Google Maps. And now, the scan report shows detection information and recommendations. You can even save reports as a PNG, a function I added later. Back in scan history, you can delete or revisit past reports. Here's an older scan. You can skip the 3D model by using the Take Photo option. Here, I'm selecting an image of malignant melanoma from my local gallery. The model flags it as potentially malignant and advises medical consultation. In the profile screen, users can customize their demographic information. Switching to female updates the 3D model to a female version I built as well. You can also set your age and race and take an embedded Fitzpatrick skin type test, a scientifically standard 5-question quiz that determines UV sensitivity based on your natural skin color, tanning, and hair tone. And now, here's DermiBot, an AI assistant chatbot I built using the Grok API in Llama 3.3. It answers questions and helps users navigate the app, but never diagnoses, and instead always refers users to professionals. And notice, when I access the chatbot across different screens, the conversation context is also preserved. In settings, you can toggle notifications and switch app languages. Dermi supports 8 languages: English, Chinese, French, Spanish, Russian, Swahili, Arabic with right-to-left text, and Hindi, all integrated via I-18N. Under support, there's About Dermi in terms of service, which explain that this app is not a diagnostic tool, but a free resource for accessible skin health information. The privacy policy also ensures no images or personal data are stored. The help screen provides multiple support options, including direct email support, a 4-step scanning guide, and a comprehensive FAQ on accuracy, flag lesions, and data privacy concerns. Finally, back in Find Clinics, you can open Google Maps directly for driving routes or viewing clinic addresses right on the map. This makes professional follow-up very easy once you've done a preliminary scan. And that's Dermi, a completely free, AI-powered, multilingual skin health and cancer detection application I've created. I kid you not, the entire process was the biggest hurdle for me. I started with no knowledge of AI and a small coding background, so the challenge wasn't just one bug, it was building the whole 12,000 line app and also a complex CNN. There were times when I wanted to jump off a cliff, but thank God I didn't. Besides all the technical skills I've developed, my biggest takeaway has been a bit more philosophical. Building this app and this challenge as a whole has taught me that complex fields aren't guarded by innate genius or talent, but are actually very accessible in this day and age, especially with a bit of curiosity and grit. As for Dermi's future, it's not hypothetical if, it's already happening. I'm currently developing Dermi Vision, a novel pipeline using GANs and multispectral input analysis to combat racial bias in AI dermatology. I'm also expanding the model to classify over 100 specific conditions and working with local doctors to clinically validate DermiScope, the low-cost 3D printed dermatoscope I'm prototyping. The ultimate goal is to democratize skin cancer detection, making it a free and accessible right, not just a privilege. Finally, I'd like to thank my teachers, Alyssa Ment and Craig Harper, for their support. And with that said, thanks for watching, and see you next year.